Hi, this is Alex and welcome to Computer Science. This is the second episode and it's about Booleans and Logic Gates. So, what are Booleans? Booleans have two values, true and false. Or 1 and 0 as you saw in that binary episode. So, 0 is false and 1 is true. If you're talking about light bulbs, 1 would be on and 0 or false would be off. And 1 would be the truth and 0 would be a lie. So those are all the things that they could be like. So yeah, they're similar to those in a lot of ways. And in fact, some LEDs, which are I think light emitting diodes, I think that's what it stands for. Okay, so yeah, that's what it stands for. And they turn on if it's 1 and they turn off if it's 0. So yeah, that's what Booleans are. And a transistor, so a transistor has two electrodes. It has an input electrode and an output electrode. And we're going to label them IE and OE. So, there's also a control wire, C, which is a lot like our condition, which also starts with the C, by the way, and a semiconductor. It's called a semiconductor because it can either open or close, depending on what the control wire is set to. So, yeah, I think the control wire is actually more of the input than the input electrode. That's more of the current. Yeah, that's more of a current. And C, the control wire, is more of the conditioner input. So there's a truth table for a transistor. A transistor could also be known as a buffer. And buffers don't do anything. Like, they just leave 1 is 1 and 0 is 0. There's another gate called a NOT gate that actually inverses the input. So let's see how this works. So there's the input, and if the input is true, then all the current will flow to ground. Ground is kind of like a black hole. Everything will be sucked toward it. It can't go anywhere else. So it wouldn't go to the output wire if this input is true. So yeah, ground is like a black hole. But if input is false, then current can't get sucked into the black hole and it will actually go to the output instead. So let's see the truth table for it. If you input 1, it outputs 0. If you input 0, it outputs 1. So now we're going to step into the world of binary logic gates, also known as logic gates that take in 2 inputs. So there's the current, and the inputs are named A and B. And so let's say that A is 1 and B is 1. The AND gate returns 1 if both A and B are 1. And the current can't flow through if either of them is 0. truth table looks like this. The only time that the output is 1 is if A is 1 and B is 1. There's another gate called the OR gate. So this one, oops, I forgot to label transistor B, but you always know it's transistor B because I'm telling you it is. But I forgot to label it. So current can flow through that wire. It's not labeled current, but by now you should already know it's current. So if A is on, they'll flow through A, but if B is off, they'll not flow through B. But it doesn't matter because A will just go to the exit. If B is on but A is not on, it will do the same thing. And if both of them are on, it'll also go. The only time it doesn't go is if both of them aren't on, because then it's blocked. This is the truth table for the OR gate. The only time that it outputs 0 is when A is 0 and B is 0. There's another gate called an XOR gate, and its truth table is very similar to the OR gate. But if you were looking in the bottom right corner, I'm switching it again. In the OR gate, that's actually 1 if both of them are 1, as he explained. But in the XOR gate, it's actually 0. Well, luckily we actually have a gate for that, the AND gate. So it seems like OR but not AND. So this is how you make an XOR gate. It's basically an OR gate with a smile. That's a symbol. Oh, by the way, I forgot to show you all the symbols. So the AND, So that's the transistor, and the NOT gate symbol is that triangle with the dot. By the way, the buffer also is a symbol. It's just triangle without a dot. And the AND gate symbol looks kind of like a D, but really long. And the OR gate, well, yeah, this one's pretty messy. You can actually see how this actually looks, but this is just the messy version because there's not actually a tool to make an OR gate. But the OR gate symbol should look something like a spaceship. And the XOR gate looks like an OR gate with a smile. I already said that. So the XOR gate, you take in A and B this time. This time you don't use the current because the current is already passed by. So you do the OR gate on A and B. And remember that AND gate that we had to invert? Well, you pass it into a gate called a NAND gate, which basically inverts it at the output. It basically inverts the output. So that's the NAND gate, and its symbol is an AND gate with the dot. So then we're ANDing both of those conditions into the output. Hopefully that made sense. So there are 16 possible logic gates. I found this at the Universal Logic Gates part at I think it's called It's About Circuits or All About Circuits. I think it's called Everything About Circuits, maybe. If you know what it's called, well, tell me what it's called. I think it's called All About Circuits. So you should probably pause your video right now and look at all of these gates and see if it makes sense to you, because this is pretty good. And it's pretty fun to look at. And finally, with all those gates we saw, imagine you're voting for president. When you're testing people, maybe with 4 people, a 4-vote system would look kind of like this. You're ordering everyone. But this system actually has problems. So let's say that you're trying to vote for this guy who like picks his nose all the time, and he's like really weird, and he's so dumb that he's just like, and nobody is sure why this guy signed up for president. It's just like very weird. But there's one guy out of 4 who's voting for him. Let's say that he's also weirdo. Well, then if you OR everything, well, you'd end up with 1, and that one guy will overpower the 3 other guys, which doesn't make that much sense because the other guys are supposed to overpower him. So let's go to another system. It's the same thing, but it uses AND instead of ORs. So this seems better, but it still doesn't work. In fact, it's just as bad at that as the other one. So with this one, it uses AND gates. But let's say this time you're voting for the series guy, the guy who's very smart. The guy who does not pick his nose. So let's say that weirdo doesn't vote for him, but everyone else does vote for him. Well, then the weirdo will still overpower everyone, and it'll end up with 0. Do not vote for him. So, yeah, this is wrong again. Well, what is the solution? What? Oh, okay. So in the next episode, we're going to learn what this circuit is and what it is called. So it takes in 2 binaries. One of them is a positive wire and one of them is a negative wire. I forgot to put closing parentheses. And they go into this special circuit that outputs a Boolean. See you in the next episode!